So we're going to finish off our notes from yesterday, talking a little bit about how to algebraically solve for these. And we did this in some ways on what we talked about a little bit yesterday, in that we can find our zeros of the function, again, by doing some factoring, and then test the values on a number line. So we're still going to do test points. It's just going to be a little bit different than when we did it with the graph and do it with a parabola. So down here, I'm like, okay, this is kind of like a diamond. So I need two numbers that multiply to -8 and add up to -2. -4 and 2. Once I get here, of course, to find zeros, I need to set this equal to 0, which means I'll take each set of my parentheses and set those equal to 0. When I find what those two x values are, and in this case, that's going to be 4 and -2, because of course I have to do opposites to get them solved for. These are my x-intercepts. And so when I do it now on a number line instead, I'm just going to count by 2s. It'll work a little bit easier on spacing here, but you could count by 1s if you wanted to. And what I'm going to do is I'm going to take these 2 points and I'm going to graph them like I was graphing. Now here's the part that gets a little interesting. I take a peek at this and I go, okay, before we'd always been doing parentheses or brackets. Well, with this, we're not going to know some things right away. So here's what we're going to do instead. I notice here, I don't have a line underneath, so it's just going to be the greater than. So I'm going to go to those two values. And just kind of as a self-reminder, I'm going to put a couple of open circles there. And here's what my task is then going to become. I need to test out to see which of these 3 areas where my answers are at. Now typically what's going to happen is it's either going to be shading in between, like when we did and statements before, or they're going to be going out to the edges like the ors did. This first one we're going to test all of them, but after that you can sort of make the assumption if this one works, these won't, or if this doesn't work, these will. So here's our idea. We're going to break this graph off, bless you. It's going to sort of put a little bit of a dotted line through here. So let us physically see. Got 3 sections that we're working with here, and we want to test a number out of each one. So in this first section, any number less than -2 I could plug in and test. Well, I see -4 there, so I'm just going to use -4. Okay, so if I test -4 in, all I'm going to do is I'm going to go back to my original problem, and I'm going to plug the -4 in where the x's are at. I'm going to see if it's true or not. So like, let's see. Here I'd have -4 squared minus 2 times -4 minus 8 is greater than 0. Now here's some of you madly typing away on the calculator here. So somebody help me out here. What's all this business going to equal? 16. So is 16 greater than 0? Yes. So since that's true, this area, starting at this point and going forever to the left off to -infinity, is going to be true. Now we talked about, typically that's going to tell us that this is going to work and this isn't, but we're going to literally try it this first time through. And I'm losing pens. So somewhere in between -2 and 4 in our middle section here, what do you think a good number would be to use to plug in? There might be ones even better. Yeah, because 0 wipes things out. It makes it fast. So like for instance here, I'm just going to write this down a little lower. If I test out 0, let's see, 0 squared is 0. Minus 2 times 0, that's 0. So 0 minus 0 minus 8 is -8. greater than 0? No. And we sort of thought that, so I wouldn't be coloring in here anyway. But it just lets me visually see that if I'm wondering sometime, why did I color in those places? And then finally, and I'll even give you another hint here when we get done. When I get to this last area, I'm pretty sure this one's going to work. Now I see 6s here, so I'm just going to use it. If I test out 6, so I'm going to plug that in, 6 squared is 36, minus 2 times 6 is 12, minus 8 is greater than 0. I'm just testing to see how things are going with that. So 36 minus 12 is 24, minus 8 is 16, and since that's greater than 0, that's true, it means I'm going to be coming out to this area with my other value, and now I'm ready, just like we used to do. I can write this in interval notation because I can physically see where my values are going to be. So my interval notation would start way out here to the negative left, which is negative infinity. And then it keeps coming until I get to that negative 2. And then it stops for the moment. We have this little gap in here. And then we start up again at 4 and go off forever to the right. Now, is there a little bit of a shortcut way I could get to an answer on this? There is. And the key all lies with my inequality arrow. If I get that greater than, because remember, greater than from when we had it before is the same thing as an or statement. And we always talked about how the ors, they always went out from each other. So if I look at this right away and I see that it's an or and I can recognize it, I could actually go, once I get to my intercepts, straight to the interval notation. It would just be the lesser one on the left and the greater one on the right. Can I draw the picture? Sure. Can I test points? Absolutely. But if you're that shark, if you kind of say, ooh, I sniffed something out here, this is greater than, that's or, you can go straight to the interval notation on that and not even have to think about doing it graphically. But again, if you're more visual, this is probably a better way to go for you. Yes, ma'am? I would use a bracket if that were or equal to. But yeah, otherwise the parentheses are the way to go on this one. But we're going to bracket up the next one here. Now this one, a little different of a situation because I can't just do a diamond on it. Now some of you might just do mental math on this one. Some of you may say, I want to do a slide and divide. I don't care which one we do. So I am going to go ahead, since it seems to be a little more of a majority with some of you, that some of you like to just be consistent. Consistency would be sliding and dividing here. So remember, if I'm going to go that route, we're going to slide that guy down here to the end. And then all of a sudden he turns into a diamond, which we like, once I squeeze myself in here. Multiply to 6 and add to 7 would be 6 and 1. But again, I'm not done at this point. And that's the thing I have to remember, because some of you will get to this point and then you'd set those equal to 0 and say you were done, but not quite. That 3 that we slid now comes back in with the division part. Well, 1/3 doesn't reduce anymore, so that's just going to swing back to the front. But 6 divided by 3 does reduce. It's 2, so there's nothing left to slide back to the front because there's no fraction left. Once I get here, once I get it factored, I'm going to set each of those equal to 0. And I'm going to find my 2 intercepts. And yes, you can get fractions or decimals on these. That is absolutely, positively possible. And in this case, well, that's just the way it is. And again, these are my x-intercepts. These are when I go to graph it, these are the points that I'm working from. Oh dear. So, if I have those guys, and I'm trying to do some graph work here, okay, I always like starting a little further back than my worst one here. But somebody's like, wait a minute, I don't see your negative 1/3 somewhere. Because remember, we want to work on number sense. I don't just want to stick a random third somewhere, because then I don't really get what's going on. So here's what we'll do. Like Madison had mentioned, we got to watch for this parenthesis bracket thing. Since this is or equal to, this time to remind myself of that, I'm going to use a colored in circle here. And again, negative 1/3 is kind of close to 0, but not exactly. So we'll kind of ballpark it here. So once I get those, again, it's going to cut my graph into these 3 pieces. Now, again, there's a hint. This time my inequality arrow is pointing at my factored portion, at my quadratic. So on this one, that typically would be an and statement. In other words, we're probably going to be just coloring in the middle. Well, let's test it out and see if that's true. Negative 1's just sitting there waiting for us. Bless you. So if we test negative 1 out, again, you need to use parentheses when you're doing this. So if you do decide you're going to go to the calculator with this one, I'd do 3, negative 1 in parentheses. So plus 7 times negative 1 plus 2. Okay. So is negative 2 less than or equal to 0? Yeah. Since that's true, I'd color in this area. And like I said, the difference is going to be, if you color in the middle, you're not coloring in the outside. If you color in the outside, you're not coloring in the middle. So really, the middle is the only one you have to test on all of these. Because if that works, that's the only one that's going to work. If these, not so much. So my interval notation will be really easy on this one, because I'm not going forever in either direction, so there's no infinity involved. So I just start at my leftmost point, and it'll be a bracket, since it's or equal to, at negative 2. And then my furthest point to the right is the negative 1/3 that we figured out a minute ago. And I should get that written in here. And that's it. So again, though, if you are more of a visual learner, graph it and test something out, at least the middle, to see, and then you can do your interval notation from the graph. If you look at this and can tell it's an and color in the middle, that's great. Okay? Now there's one other thing that I may have forgotten to mention yesterday. Not that we wouldn't know how to do it anyway, but you'll notice when we were doing the notes yesterday, when we were doing these back ones, these always factored, and this always factored. That's not always going to happen. So here's where I get to help out. So for the packet we're going to be working on today, so this guy here is homework check number 9. Okay, it's going to be our third assignment. What happens if I get one of these in standard form and I can't factor it? I can't multiply two numbers to get 17 that add to 8. It just doesn't work. So when that happens, we got to go back to another tool that we had before. Since I need to find the vertex anyway, and we've gotten some practice on this with extra credit and back in the first section of our unit, our negative b over 2a comes back into play if it's not factorable.
So for number 1, it will be negative 8 divided by 2 times 1?
That's right, because here, my a value would be 1, my b value would be 8.
And the c value would be 17.
That's true. If I needed the c, my c value would be 17. So again, the formula is negative, or the opposite of b, the opposite of 8 is negative 8, over 2 times a. 2 times 1 is 2.
Which would be negative 4.
Which is negative 4. So that Negative 4 is my x value for my vertex. Now at this point, and I'll show you both, because again, it's pretty evenly split between most of you on how you go after it from here. My calculator people, I will show you in a minute, but you probably even know what to do from this point. But if not, we'll get you there. But if not, okay, if you're not a calculator and table person, what you could do here is you could go ahead and you could just plug that negative 4 in parentheses, of course. And if you don't have access, either online or a physical graphing calculator to use outside, it's probably good to at least do a couple this way so you remember how to do it. And so whatever value I get, that's where my y value is going to be, because I just get the y by substituting in for x. And then I'm going to work on getting some of my other values. Now remember, I'm not going to have to do this for all of them. These two guys are going to be the same as far as their y values go. These two guys are going to be the same. So I just am going to pick one number from each of those little designs I made and plug those in, just like I did here. So like if I choose negative 2, let's say, I'm going to do the exact same thing that I did in the one right above, except now instead of using the negative 4, I'm going to use the negative 2. And whatever answer I get for negative 2 will also work for the negative 6. And if you're not sure, if you don't believe me, you can test it out, because I know I'm going to be right. And then I'm going to do it one more time for one of these. It doesn't matter which one. And I'll get my last value in there for both of these. And I'm going to be ready to plot those points and graph it. Now again, for my calculator people, you have the option of going to y equals and typing the equation in, the x squared plus 8x plus 17. And once I know what the x value is of my vertex, I know how to use the table. Because as long as that x value is in the middle, if I've done it right, I should visually see symmetry going on in the table, and I do. And you'll notice we cranked these out on our own, but if I look at the table now, I see the exact same values. For my x equals negative 6 through negative 2, I got the same things. So it's another way of me being able to double check, even if I normally don't use that. So once I get that set, I'm going to plot my points. I'm not going to connect them quite yet, because I've got to remember here a couple of things about my graph. One, am I going to connect with a solid or a dotted line? Dotted, because again, this guy right here. Because again, when it's not or equal to, we're going to use a dashed line. And then again, we're just going to test a point out.
Negative 4, 4.
That would be perfect. Something that's towards the middle. So if I tested something like negative 4, 4. Now again, remember, first number's my x, second one's my y.
So it would be 4, it would be less than negative 4 square.
And then I would just rewrite the right side of that, right, replacing every x with negative 4. I got to do them all, though.
Yeah, I messed up.
So, again, I can either do this in my noggin or I can type it in, and I'm just going to keep saying it. Whatever number you plug in for x, it needs to be in parentheses. Otherwise, it can absolutely affect your answer. So, is 4 less than 1? No. That is
okay,
false.
I messed up on that one. Because I didn't write the entire thing.
And false just means we shade or color on the outside of our parabola. If it's true, we do it on the inside. Okay. So if you do try to factor and it isn't working, we got to go back to our vertex being negative b over 2a. We're just going to use a different tool to get the job done. But then if you want to go to the table and just fill it in this way, that's fine. Let the calculator do its thing. The one other one I want to do with you, to make sure that we've got you on a firm setting here. Yes, ma'am? Something went wrong because the numbers on these, because I've done them all, you're going to be on the chart. So we'll check there in a second to see what's happening on that one. Could be any little thing from just a sign issue to something like that. We will find the answer. The last part's on the last sheet of the packet. We didn't necessarily talk yesterday about when they're in vertex form, but this is actually easier than the others. Because remember, when we're back here, when we're in vertex form, our vertex is sitting there looking at us already. We don't have to do a fancy formula or any calculations. We just look at what's there and say, hey, so what's my vertex going to be for number 9? 1, 2, because it's the opposite of h, so it's the opposite of negative 1, which is 1, and 2. Now, do I still need to make a parabola? Well, yeah. But again, whether I put it in here and then mentally work through these, which I'm going to do on this one, or if I plug this in and then use the chart, that's okay too. So like for instance, let's see here. Let's say I use 2, because these will be the same. So 2 minus 1 would be 1. 1 squared, that's still 1. Plus 2 would be 3. Get that in there. And then if we use 3, let's say. 3 minus 1 is 2. 2 squared is 4. And 4 plus 2 is 6. And again, if you did that with the calculator and just the table, that's fine. But once I get that table done, I'm going to do it the same way I was doing it before. I'm basically just going to look and I'm going to say, okay, looks like it's a dotted. So I'll get my dotted in there. Then I look and I go, okay, well, let's see here. What would be a good test point for this one? Any ideas? 1, 4. Sounds like a plan. Again, my x is 1 and my y is 4. So let's see here. So we'd have 4 is greater than 1 minus 1 squared plus 2. All right, let's see here. 1 minus 1 is 0. 0 squared still 0 plus 2. Is 4 greater than 2? Yeah. Yes. And since this one's true, we just color inside our parabola. Okay. So your job is to wipe these guys out. And if you need to kind of jump back into some of them from yesterday, that's fine. You've got some time. Again, just giving you a heads up. The next homework check will be Wednesday, because we'll have an assignment on Monday to do.
Next Wednesday.
Yep. So, but there's time. There's time. And so then we'll be heading here soon towards the end of this unit. We've got one more section to work with, and then we'll start doing some reviewing for the unit test. Okay, so let me get this